9.4b. Okay, yesterday we did 9.4a, which was finite series. Today we do infinite series, or otherwise known as infinite. I spelled it wrong already. Infinite. Infinite series. The WASC people are here this week. I spelled instantaneous wrong in my last class in front of them. Oops. All right, here we go. Okay. First, we're going to find some sums. Some sums. Okay, so let's go ahead and define what an infinite series looks like. An infinite series is going to have your sigma, your summation notation. And let's say we start at n equals 1, and we go to infinity. We did one yesterday, remember, to kind of get us like a little snippet of what we're doing today. And then this would be of a sub n. So what this looks like is it's a1 plus a2 plus a3 plus dot, 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 with no end in sight, okay? Now, you can add up an infinite amount of numbers, and it's going to converge to one number, or it will diverge, okay? So there's two things that it will do. So this sum can either converge. If it converges, then S will be the sum. It will have a sum of 2 or 10 or negative 12 or whatever. But an infinite amount of numbers can have a sum. Sometimes it doesn't, though. Okay? A series will diverge if it has no sum. It just either keeps going to infinity or to negative infinity. Has no sum. All right, we're also going to do partial sums. Partial sums are finite, so you'll have an infinite series, but you'll just be asked to sum up a finite number. So a partial sum is the sum of a finite number of numbers. Finite number of numbers. Sounds kind of funny. Ooh, they go through limits and stuff, but we won't do that. We won't do that. Okay. All right, so let's do some. Here we go. Number 1. Let's go ahead, and what we're going to do is we're going to find the first 5 partial sums. The first 5 partial sums. Okay? And then we're going to say, will this converge or diverge? You'll be able to tell after you find the first 5, okay? You'll see that it appears to be approaching a number, or it appears to be going to infinity. So we're going to do 1, 2, 3 of these. So letter A. All right. I think we did this one yesterday. I kind of want to do a different one, though. No, we'll just do this one. Okay, suppose that I have this infinite sum of numbers. 0.5 plus 0.05 plus 0.005 plus dot, dot, dot. Okay? What I'm going to do is I want to find the first 5 partial sums. I'll show you what that looks like. They want you to write it in brackets, okay? And they want you to sum up the first one number. Let's add the first one number, 0.5. Okay? Then for the next one, the second partial sum, they want you to sum up the first 2 numbers. Okay? So 0.5 plus 0.05 is 0.55. Then they want you to sum up the first 3. Okay? Do you get the idea? So 0.555. The first 4 numbers would be there. And then 1, 2, 3, 4, 5. All right, so if you ever weren't sure what 0.55555 repeating is on your calculator, you know your calculator will do that for you, right? if you hit math fraction. I mean, 0.5 is pretty basic, but if you put 0.55555 in there and hit math fraction, it will give you 5/9. So this is what it's approaching. This is going to converge, and it looks like it's going to converge to 0.5 repeating, right? 0.5 repeating means 0.5 infinite amount of times, and that's what it would do if you kept going to infinity. So, or bless you, or you could write 5/9. Remember we did that one yesterday, which was 0.3, 0.03, and it converged to 1/3. Okay, let's do another one, letter B. Suppose that I'm going to add up the numbers 10 plus 20 plus 30 plus 40 plus dot, dot, dot. Okay, and I have to find the first 5 partial sums, and then I have to tell whether this is converging or diverging. So the sum of the first sum would be 10. The sum of one number is 10. The sum of two numbers is 30, 10 plus 20. The sum of three numbers would be 60, 10 plus 20 plus 30. The sum of four numbers would be 100. You get 60 plus 40. And then the sum of the first 5 numbers would be what? 150. Perfect. Okay, so those are our first 5 partial sums. Are these numbers converging to anything or diverging? They're diverging, yes. They're just going to keep getting bigger and bigger and bigger. And if you do this an infinite amount of times, you will get infinity when you add them all up. Okay, last one of these. Here's an interesting little series. 1 minus 1 plus 1 minus 1 plus 1 dot, dot, dot. Okay, so let's go ahead and write down the first 5 partial sums. So the first sum would be to sum up the first number, which is just 1. What's the second sum? 0. 1 plus negative 1, 0. Now add up the first 3 numbers. So the sum of the first 3 numbers would be 1. The sum of the first 4 would be 0 and 1. And you see a pattern there, right? Now, is this converging to a number? No, it's not. It's going back and forth between 0 and 1. And it's funny because back in the old days when they did this stuff, they said the answer was 1/2. And they were wrong. They said that for a long time. So this actually diverges because the number oscillates between 0 and 1. Ooh, oscillates. That's a good word. All right. Now, what we want to do is we want to focus on the ones that do converge. So when's that going to happen? It happens right here. The ones that will converge are going to be our geometric series. Okay? Arithmetic series, if it's an infinite series of numbers for arithmetic, it will never converge, ever. But if you have a geometric series, it will converge sometimes. Not all the time, okay? All right, a geometric series, an infinite geometric series converges if and only if. That means it goes both ways. You can read it that way, you can read it coming back. If and only if the absolute value of r is less than 1. Okay? In other words, r has to be between -1 and +1. Has to be a small fraction. Okay? Not like 7/5. I know 7/5 is a fraction. It needs to be like 1/2. It needs to be between -1 and +1. And not 0. Not 0. Okay. And here's what it is. The sum for geometric infinite series is so cool because yesterday's formula was super complicated. A1, 1 minus r to the n over 1 minus r. Does anyone remember this one? It's just A1 over 1 minus r. Crazy. Okay? You memorized that last year. And then you forgot it because you took the test and then you were done, right?
Yeah.
Same. I know. Okay, you don't have to memorize that though. All right, so let's do some. Here we go. Number 2. Find the sum if possible. find the sum, if possible, of course. Letter A. Let's take the sum from k equals 1 to infinity for 3 times 0.75 to the k minus 1. All right, so you need to look at a few things before you do it. You can plug these numbers into a formula, and you might get it wrong because you might not be able to, okay? So let's see if we're allowed to, if this sum actually works. So what you want to do is you want to find out what R is. First of all, this is geometric. It's an exponential equation, okay? You can write out the first few terms if you wanted to just to make sure that it's geometric, but it is. And R is 0.75. Is that a good R? Is that okay? Yes, it is. It's a great R. Okay, so here we go. We're going to find the sum of the infinite amount of numbers for this using our formula. So we're going to do a sub 1. A sub 1 is always to plug the number in down here, plug it in. It starts at k equals 1. So I get 0.75 to the 0, which is 1, times 3. So a sub 1 is 3 over 1 minus 0.7. If you're going to put this in your calculator, make sure that you do 3 divided by parentheses 1 minus 0.75. And you get 12. Does that just seem wrong to you? It does. It feels wrong, right? It's because we're finite people. We don't understand infinity, you know? Let me explain it this way. Let me do this one with you. B. Suppose I have 1, and then I'm going to add a half, and then I add a fourth, and then I add 1/8, and then I do that an infinite amount of times. Okay? I want to show you, not just, oh, here's a formula, let's plug it in. I want to show you pictorially what that looks like. Okay? With little fractions here. So let's say that I have 1. I have 1 whole circle. There it is. Yay, it's all filled in. Okay? And then I'm going to add now a half. Maybe it's pie. Ooh, it's like pie, not like the number pie, but food pie. So I have a whole cherry pie, and now I'm going to add a half a cherry pie. And then I'm going to add a fourth of cherry pie. And then I'm going to add an eighth of cherry pie. There's an eighth. And then I add a 16th and a 32nd, and guess what? I do that to infinity. I don't stop. I know, we feel like we have to stop, right? Because we do stop. Our lives stop, or, you know. But in math, we go to infinity, and guess what the answer is? It's 2. I have this cherry pie plus that cherry pie makes 2 whole cherry pies. The answer to that is 2. Isn't that weird? It's like I always talked about, like if you take half the way to the door each time, you're never going to get there. You won't, because it's finite. But if we did it an infinite amount of times, we'd reach the door. Yeah. Go half the distance, half the distance, half the distance. You'd never get there. But if you did it infinity, you're at the door. Okay. Let's do another one. Let's do 2 more, and then we're done. Let's add up the numbers from n equals 0 to infinity. It's a really ugly sigma. Negative 4/5 to the n power. Okay. First, you have to make sure that you're allowed to do it. Okay? You have to make sure of 2 things. 1, it's geometric. Yep, it's exponential. And 2, what's R? R is negative 4/5. That is between -1 and 1. We're good. So let's go ahead and put it into our sum formula. The sum of infinite numbers would be a sub 1. A sub 1 is to take 0 and plug it in. What do you get? 1. Good. Over 1 minus negative 4/5. Okay? When you do that in your calculator, don't forget to put parentheses around the denominator. And then when you figure that out, low battery, no. 1 divided by parentheses, anyone get it? 1 minus negative 4/5. 0.55555. Hey, we've seen that one, huh? Math fraction, 5/9. We saw that guy earlier. How funny. There he goes. He showed up again. Or she. I'm going to be sexist. Okay, and then the last one. The last one, it's a fun one. sigma n equals 1 to infinity for pi over 2 to the n. Okay, you get so used to doing these that you just go straight to the formula and you don't even think about it. Well, let's think about it. What is pi over 2? Half of pi. Pi is 3.1415. Okay, is that bigger than 1? Yeah. Okay, so this right here, this series diverges. Okay, so I did that on purpose to stop and look at the problem. Don't just go, because if you did, you plug it into the formula, you're going to get the wrong answer. Formula will not work for this because the formula only works when r right here is between -1 and +1. And pi over 2 is bigger than that. Okay, you're done.